Our next speaker, Dr. Catherine Rosenfeld, is a senior research scientist at IDM. She's led a diverse set of projects at IDM, including kind of measles vaccination campaign planning and modeling for that, the impact of behavior change on COVID-19 transmission, and helped with efforts in the design of software and implementing models in IDM. And it's been a pleasure working with Catherine on some of the kind of AI readiness for models and model development over the last year. And so please join me in welcoming Catherine to share her thoughts about where this is going to go.
Thank you for that introduction. Can you all hear me in the back? Okay, thumbs up. All right, great. So I'm really delighted to have this opportunity to talk to you about really what I think of as a thought experiment that we've been working on over the past couple months with partners here at IDM as well as external to the org. And I'll just indicate that I think there's a lot of work being done in this space, whether explicitly or not. Just looking at the program, so many of the talks and posters are in essence about how to take the ideas and work that's being done and make them be impactful, have them change the world. And while if you look between projects, how this is done in practice will look very different, we might agree in terms of three main ways that this is done, in terms of being able to understand the problems, being able to help formulate policies, and then assure that those policies are being implemented effectively. And this is, of course, all done in partnership, working with people in the policy, in the public, and also the scientific sphere. And these three categories I drew from this report from the UN Scientific Advisory Board, which was published in 2016. And I know many of you are at the back, so I'll just point out a few of the major findings and recommendations from that publication. And also highlight that a lot of the talks that I've seen and I think we'll see speak to a lot of the challenges in this document. For example, yesterday there was a great talk about being able to build networks, global networks for these solutions or these problems. And then also, I think underlying a lot of the talks is this need to understand each other's perspectives across these different spheres. And then so many of these of this work is about being able to use data, scientific data, new methods to be able to learn new things from new data that you have to be able to manage and handle the growth of effectively. And in this particular presentation or talk, they really talked about this data revolution that was going on in 2016. And I think now if this document were being written, it might look a little bit different. It would look very similar, but I think it would have to talk about this AI revolution that's happening, which, you know, in terms of looking at data, I think is captured pretty well by this Google trend, right? The search for AI and generative AI, where you can see over the past 5 years, this huge wave in terms of people looking on Google for these terms. And this idea of a wave is something that I think comes up a lot when you talk with people or you go to different venues. And I'm not entirely sure that it's the right one. So to draw inspiration from art, the idea of a wave, it can be one that's very it's very challenging. It's one where we may not have a lot of agency. It's destructive. It's something that is scary. And I want to maybe change that mindset and think of this more as a situation where we are now living with the ocean as a resource. The ocean can be very powerful, can be very devastating, but it can also be a source of great opportunity and a resource if we build up the correct norms and infrastructure around it. And so that's sort of the idea that I want to really drill down on, and in particularly how it relates to this question of how we can take science and really amplify the impact using a lot of the infrastructure we already have and we know is really important and impactful. And I'm not going to say we should replace politicians or scientists with AI, nothing extreme like that. And in fact, I just want to drill down on one specific component of this problem, which is the question of, I'm going to call it scientific review. How do we learn about new resources and in a way that we can create connections between people and the experts associated with it? And to do that, we're going to talk a little bit about the challenges and developments in this area specifically. And then I'm going to propose a framework and talk about an example application that I think highlights some important ideas in this space. So I think everyone in this room will have a set and a method for doing scientific review, for learning about new ideas or reminding them of ones that they already know about. A lot of this has to do with tools related to search, Google search, archive, JSTOR. These are ways to learn about things, to find things, and also to organize your ideas. But there's a lot more to scientific review than just finding things, the search. I would argue that there's also steps of synthesis, distilling what those resources say, evaluation, making sure that only high quality and relevant data informs the conclusions that you draw, and then also integration. How do you weave together that information into a coherent narrative? And if you look across the past year or two, there's a whole new world of tools that relate to scientific review. And a lot of them are now starting to impact these other steps as well, particularly, I would argue, synthesis and integration. And many of these tools integrate large language models to help you understand and distill, for example, papers that you might be interested in. But along with these tools, there's also this growing body of, I would say, cautionary tales, right? The lawyer who used ChatGPT to put together a briefing that had lots of resources that were not real. The model from called Galactica that could just as easily give you a really detailed article about chemical engineering as it could about bears in space, right? And so we know about these issues, hallucinations, bias, data quality that Jessica really spoke in great detail about. And I would also argue accountability, right? When something goes wrong, there has been a lot of accountability in terms of, or I wouldn't say has been a lot, there has been discussion about accountability and who, right, is having to deal with the mistakes or things that we see being problematic in the models and results that are being released. But at the same time, there's a lot of work that's being done in this area where we see vast improvements in these issues. And this list here is not exclusive and also not complete. But I want to highlight some of the sort of qualitative solutions in this space a little bit. One, you see a lot of improvements in methodology. You might see some acronyms that are familiar, like RAG acronyms that look familiar, like RIG, but may not be yet, as well as other methodologies that maybe you haven't heard of, but are being used in some really high quality and relevant models that you might use day to day or week to week, depending on when you raised your hand at the beginning of the session. Now, in addition to the methodology, there are also other tools in this space. And I wanted to highlight one because I don't think it's brought up a lot, but it is legislation, right? There are efforts to legislate how these models are being developed and used to be able to address these problems. And another is this issue of data, which I think I would just reference Jessica's talk as a really good resource to think about that. And it's really interesting to also think about where we are with data and where it's going, because I think there's this bifurcation in terms of how people think and deal with data. One is this space where data is becoming a currency, right? A lot of data is now being sort of pushing towards data agreements where these companies have to they can't just scrape all the data from the web, right? For New York Times articles or things like that, it's a resource that they can't necessarily access. But at the same time, in the scientific community, there's a huge push towards open access data, right? All the papers that you're publishing, there's a lot of pressure to put them out in the open so everyone can see. And I think there's a lot of good reasons. There are many good reasons to do that. But this is a very different way of thinking about data and information than what's being done in that other sphere. And so it's really interesting to stop and think about what that means for the data that's going to be going into the next generation of models and what is available for people to use and try to build different applications. And so in sort of pushing on this theme, there's really this sense of like bring your own data, this BYOD, whether or not it's data that you have that you're working on and know intimately, or data that you see out there and you want to learn more about, and aggregating that data and then applying a tool. And I think that when you look at what's around and what's available, this is a pattern that is really common to see. But I want to stop and say, like, is that the only way of doing it? And what are the implications of having that be the default? And so particularly when thinking about how you might translate science to policy, there are a number of metrics and things you might be concerned about, which I list on the left. And I think there's a really high fascination and emphasis on performance, and for good reason. You want to see these things work, because if they don't work, are they going to be useful? But my attitude is that there's a lot of work that's being done in this space, and there's a lot of really impressive work that's being done in this space, and it's not the only problem. And in fact, I wanted to focus more on the problems in the bottom half of this list, which isn't to mean that it's less important, but just to mean that I haven't seen as much work being done in here. Not to mean there's no work, but just it's not as often that you see. And in particular, this question of ownership and accountability and transparency. And what we proposed was a framework that's centered on establishing and maintaining the connection between the people who generate the data and the people who use it. And to do that, you sort of have to switch the paradigm of the people who want to use the data, collecting the data, bringing it to the tool that they then use, and building up, and then asking questions, but rather having the tool be more directly associated with the data and the people who own it. So we built this a prototype of how this could be done in practice, and we have both a preprint and also Python code with several examples that I encourage you to explore. And in the vein of this talk, please come talk to me if you have questions. But basically, we split the idea into two parts. First, the step of synthesis, and then another step of evaluation. And we really focused on how could we have this tool be something that the scientists, you all could own and have be very directly associated with the data, a paper, tables, model results that you understand and that you own. And to do that, we imagine, or we focused on basically building layers or interfaces. One that we call actions. This is something that you also see in the literature in general. This idea that when you want to learn something from data, you often have to do some action to it. You need to look up a part of your paper. You need to find a cell of your table. You need to run a piece of your code, maybe with a slightly different input than before. And then the next is this idea of guidelines. This idea that you have an idea of the scope and limitations of the work that you're doing. And then basically having that large language model be the interface to those two components, the actions of being able to take a question, what type of data does the model use? Being able to map that question to a particular action. Oh, that's a question related to methods and data, and then access the knowledge base and find the answer, synthesize it to an answer that then the person who's asked the question, can read. And then along with that, in the next step of evaluation, be able to check that the answer that's resulting is consistent with guidelines that the scientist, the person who's the expert in the knowledge base, has generated. And this is similar to that LLM as a model idea that Jessica was speaking to. And so we have a couple of examples in the repository I mentioned, but one that I wanted to go into a little bit more depth was this application to an analysis on how to estimate the seasonality and susceptibility of measles from case time series. And this was work that was led by Sonia Jindal and Niket Thakur here at IDM. And they had an archive preprint as well as a public GitHub repository with some Python code. And the results of that analysis one of the important results was that they were able to provide estimates of basically high, low, and transition seasons for measles. And that's captured in the figure on the right, where I'm showing 3 different countries. And on the x-axis, you have different months. And on the y-axis, you have their estimate for the level of measles transmission. So the red being the high season of high transmission, and then the green being the low. And this is really important because it is helpful to be able to identify when you have, for example, an increasing risk of outbreaks due to entering the high season, which might help you be able to decide when you need to, for example, plan an immunization campaign. So there are really relevant results for policy in this work. Now, I briefly showed you or walked through the figures, right, up here. And then there's also a figure on the right where you can see as a function of time how that relative susceptibility of the population changes as campaigns are being run in that country and outbreaks are happening. And even with just that quick description, I think many of you might have a sense of what those figures mean. Many of you might already be like, okay, I get it, you can stop talking. And many of you might be like, Catherine, you didn't really do a great job of explaining that. And that's reasonable because data visualization, while it can be an extremely compelling and effective medium for communication, requires that the person you're talking to have some familiarity with what they're looking at. Often, even just having the text below the figure can be really key, right? You need to have some expert knowledge to be able to understand what these sorts of figures mean. Now, with the framework that we propose, instead of observation, you can switch to a mode of query, right? You can say, when is the low transmission season in Chad? And then rather than having to be able to decipher the figure that I walked you through, the framework that we proposed is able to pull that information from the knowledge base and say which months are the low transmission season as estimated by this analysis. And along with that estimate, we also, in that framework, have this added component of whether that answer passes or fails the guidelines that I described, as well as a score. And this is also very different than what you'll see often in terms of the tools that you'll see for this sort of thing, where if you ask a question and the tools doesn't think it has a good answer, it'll just be like, I can't answer that. And you feel like you're just sort of bumping up against walls, but you don't really know what the room looks like. And so my hypothesis here is that if you have something that's not working well, just show what's not working well about it and be honest. And because this tool is associated with that particular piece of evidence and has clear traceability back to the people who have generated, you know who to go and ask. Like, hey, my question's not being answered. Can I talk to you about it? Rather than if it's data that you've pulled into a large database where every single tool that you see will probably have some note being like, well, this can be wrong. You should really check it. Okay, great. That's nice to know. But it's not clear who to go to when you have questions or issues. The onus is put on the user. So based off of the amount of time here, I'm just going to quickly mention how we do the evaluation component, because I think that's really relevant, which was one of the ideas that we had, was to do this in a way that was easy and intuitive. You all have a lot of work that you're already doing, right? And more work that you would want to. Why should you have to do additional work on top of that here, right? the idea is to have standards and interfaces that are easy and quick to implement. And so the way that we did this was through a combination of having a set of criteria, things that you could not do, ands, and also a set of topics, ors, things that are okay to talk about. And then did a series of some exploration, which I'd encourage you to either look at the preprint or find me afterwards, which I can talk to you about, to demonstrate that just by using this type of formulation, you can actually get results that are stable and have agreement between models. And so I'll wrap up here with just landing on, in terms of what is important for thinking about how AI might be a useful tool to help amplify and increase the impact of all the work that you do, there's a lot of space to push on. And hopefully we'll be able in the next symposium to talk about some of these other bullet points as well. But in terms of what I want you to take away from this talk, it's really about the philosophy, this idea that this isn't a wave that is going to come and then the landscape will be changed, but rather that this is a resource that with I think certain choices in design, as well as I think the opportunity to build standards and how we think data could be used, that it could be a tool that could really enhance the science public and policy interface without replacing these really key human interactions. Thank you, and be happy to take questions.
All right, fantastic. I love the analogy with the ocean as wave versus resource. We have time for 2 questions. I didn't see any in the chat, so let's just stay in the room. Amanda's coming.
Thanks. Hi, thanks very much. My name is Amy Paul. I had a question. I guess I wasn't quite clear from the example whether the intent is this is used on a single piece, like a single study that someone would be interrogating, or whether it applies to a larger body of evidence where in the query there's some sort of synthesis or meta-analysis or judgment that's also being made in addition to how it would look at a particular data visualization or how it would look at the results of a particular study. Like, is it single piece of evidence helping translate, or is it across a body of evidence?
So the suggestion, or the way that we built the framework now, is really focusing on a single piece of evidence. But I think the wider idea is that if you have a standard in place and these interfaces built, that it would potentially be able to scale across. But I think you'd want to be very careful about building a structure like that, because I think it could be very brittle. But really, the focus is on a single piece of evidence.
Cool. Thanks.
Great. Another question right over here.
Thanks, Catherine. I think there have been a lot of conversations about model literacy among policymakers, and I'm curious if you thought about how an approach like this might hinder model literacy or maybe enhance model literacy, and if you considered that at all.
Yeah, I think that's an important conversation to have, and my hope is that it could enhance it, mostly by having a way to map some of the ideas or language, even that when you talk to someone who may not be an expert in the model that you've built, right, but has similar concepts, that maybe the language or there isn't a direct one-to-one mapping, that this sort of tool could help. But I think that you have to be very careful, right, where it's not just someone having a conversation with a large language model to learn, but rather that it's something that they can try to understand, well, what is this work, what is the relevance, and then make sure that the ability to then connect back to the people who are the experts is there and enforced. And so not enforced is the wrong word, but available.
Fantastic. Well, let's thank Catherine one more time.